The .338 Lapua Magnum is a rimless, bottlenecked, centerfire cartridge developed for military long-range sniper rifles. The Afghanistan War and Iraq War made it a combat-proven round with ready and substantial ammunition availability. The .338 Lapua is a dual-purpose, anti-personnel and anti-materiel round, but its anti-materiel potential is limited, due to the bullet's lower kinetic energy compared with that of the .50 BMG's 35.64 to 55.08 gram projectiles. The loaded cartridge is 14.93 ohm in diameter and 93.5 ohm long. It can penetrate better than standard military body armor at ranges up to 1,000 meters and has a maximum effective range of about 1,750 meters. Muzzle velocity is dependent on load and powder temperature, and varies from 880 to 915 ams for commercial loads with 16.2 gram bullets, which results in about 6,525 AJ of muzzle energy. Non-CIP conforming British military issue overpressure .338 Lapua Magnum cartridges with a 91.4 ohm overall length, loaded with 16.2 gram lock base B408 very low drag bullets were used in November 2009 by British sniper Corporal of Horse Craig Harrison to establish a new record for the longest confirmed sniper kill in combat, at a range of 2,475 am. In addition to its military role, it is increasingly used by hunters and civilian long-range shooting enthusiasts. The .338 Lapua Magnum is capable of taking down any game animal, though its suitability for some dangerous game is arguable. Unless accompanied by a larger backup caliber, there is a huge difference between calibers that will kill an elephant and those that can be relied upon to stop one. In Namibia, the .338 Lapua Magnum is legal for hunting Africa's Big Five game if the loads have a per mil 5,400 yen AJ muzzle energy. History. Initial development. In 1983, Research Armament Industries in the United States began development of a new, long-range sniper cartridge capable of firing a 16.2 gram, 0.338-inch diameter bullet at 914 meters per second that could penetrate 5 layers of military body armor at 1,000 am and still make the kill. After preliminary experiments, a .416 Rigby case neck-down to take a 0.338-inch bullet was selected, since this diameter presents an optimum of sectional density and penetrating capability for practical spin-stabilized rifle bullets. The .416 Rigby is an English big game cartridge that was designed to accommodate 325 umph pressures. One of the disadvantages of these old cartridge cases, which were intended for firing cordite charges instead of modern smokeless powder, is the thickness of the sidewall just forward of the web. During ignition, the cartridge's base, forward to the bolt face, is not supported. The case is driven back against the bolt face, which results in the stretching of the case, particularly the sidewall immediately forward of the web. When the sidewall resists the outward expansion against the chamber, the pressure stretches the case, thereby increasing its length, resulting in the sidewall becoming thinner at that stretch point. During the process, AI employed Brass Extrusion Labs Limited of Bensenville, Illinois, to make the .338/416 or 8.58A, 71 mm cartridge cases. Hornady produced bullets, and RAI built a sniper rifle under contract for the U.S. Navy. RAI found that the Bell cases did not fulfill the requirements. Pressed by military deadlines, RAI looked for another case producer and contacted Lapua of Finland in 1984. RAI was forced to drop out of the program due to financial difficulties. Subsequently, Lapua of Finland put this cartridge into limited production. The .338/416 rifle program was later cancelled when the contractors were unable to make the cartridge meet the project's velocity target 16.2 gram at 914 ams, due to weak brass cases. Final development. The current .338 Lapua Magnum cartridge was developed as a joint venture between the Finnish rifle manufacturer SAKO and the British rifle manufacturer Accuracy International, along with the Finnish ammunition manufacturer Lapua, or more officially Namo Lapua Oy, which since 1998 is part of the Nordic Ammunition Group. Lapua opted to redesign the .338/416 cartridge. In the new case design, particular attention was directed toward thickening and metallurgically strengthening the case's web and sidewall immediately forward of the web. In modern solid-head cases, the hardness of the brass is the major factor that determines a case's pressure limit before undergoing plastic deformation. Lapua tackled this problem by creating a hardness distribution ranging from the head and web to the mouth, as well as a strengthened case web and sidewall immediately forward of the web. This resulted in a very pressure-resistant case, allowing it to operate at high pressure and come within 15 ams of the original velocity goal. Lapua also designed a 16.2 gram .338 caliber lock base B408 full metal jacket bullet, modeled after its .30 caliber lock base bullet configuration. The result was the .338 Lapua Magnum cartridge, which was registered with CIP in 1989. With the procurement by the Dutch Army, the cartridge became NATO codified. The .338 Lapua Magnum fills the gap between weapons chambered for standard military rounds such as the 7.62A, 51mm NATO and large, weighty rifles firing the .50 BMG cartridge. It also offers a tolerable amount of barrel wear, which is important to military snipers who tend to fire thousands of rounds in practice every year to acquire and maintain expert long-range marksmanship. Like every other comparable big Magnum rifle cartridge, the .338 Lapua Magnum presents a stout recoil. An appropriate fitting stock and an effective muzzle brake will help to reduce recoil-induced problems, enabling the operator to fire more rounds before getting too uncomfortable to shoot accurately. Good factory loads, multiple projectile weights and factory special application ammunition are all available. Due to its growing civilian popularity, several high-quality tactical and match custom bolt actions designed for the .338 Lapua Magnum are becoming available. These custom bolt actions are used with other high-grade rifle and sighting components to build custom sporting and target rifles. Law enforcement and military users. The .338 Lapua Magnum cartridge is in law enforcement or military use with Albania, Renia Euro Sacco TRG-42, Australia, Blazella Tactical 2, Brazil, Blazella Tactical 2 a Euro used by Special Unit of Policia Federal named COT, Canada, Canadian Forces a Euro C-14 Timberwolf medium-range sniper weapon system, Colombia, TAP. Denmark, Military of Denmark a Euro Sacco TRG-42, Estonia, Military of Estonia reconnaissance units and special forces a Euro Sacco TRG-42. Finland, Finnish Defence Forces a Euro Sacco TRG-42, France, French Army, GIGN and Commandement des Opérations Copyright Rations SPA Copyright Siles, PGM 338, Sacco TRG-42, AWSM, Germany, SA 100, AMP Technical Services DSA-1, GOL Sniper Magnum, Greece, Anti-Terrorist Unit Kerma Euro Sacco TRG-41, Indonesia, Kopassus Euro Accuracy International AWSM, Ireland, Irish Army Euro Accuracy International AWM, Israel, Infantry, HS Precision Pro Series 2000 HTR Militarized Semi-Custom Bolt Action Rifle, Special Forces, Macmillan TAC 338 and PGM 338, Italy, Sacco TRG-42, Malaysia, Pasukan Jerakan Casa Euro Accuracy International AWM, Netherlands, Dutch Militaria Euro Accuracy International AWSM, Sacco TRG-41, Poland, Groma Euro Accuracy International AWM, 1 per Expedição Mendoza Cube W, Portugal, Military of Portugal, Accuracy International AWSM, Russia, Alpha Group and Sobra Euro Accuracy International AWSM and Sacco TRG-42, Singapore, PGM 338, Slovenia, Military of Slovenia Euro PGM 338, Spain, Goa Euro Sacco TRG-41, Switzerland, Sacco TRG-42. Turkey, Sacco TRG-42, PGM 338, United Kingdom, British Militaria Euro Accuracy International AWSM, a United States, U.S. Navy Special Warfare Euro Macmillan TAC 338, the .338 Lapua Magnum has been designated a cartridge of interest by the National Defense Industrial Association. It is being groomed to replace the .300 Winchester Magnum and the .50 BMG for anti-personnel long-range service in the U.S. military. On June 17, 2008, the U.S. government issued a market survey to support a requirement for a precision sniper rifle to possibly replace the currently fielded bolt-action SOF sniper systems Mk13 and the M40 and M24 chambered to safely fire factory-produced non-Wildcat .338 caliber ammunition. On March 7, 2013, the Remington MSR was declared the winner of the precision sniper rifle competition. Remington announced that the MSR had won on March 8, and it was publicly confirmed on March 9. This was followed by a $79.7 million contract for 5,150 rifles with suppressors, along with 4,696,800 rounds of ammunition to be supplied over the next 10 years. The contract was awarded on September 12, 2013. Remington Defense produces the sniper rifles and utilizes two other companies for other system components, with Barnes Bullets for ammunition and Advanced Armament Corporation for muzzle brakes and suppressors. All three companies are subsidiaries of Freedom Group Incorporated. Cartridge dimensions: extremely thick-walled brass results in a 7.40 ml cartridge case capacity for the .338 Lapua Magnum. The exterior shape of the case was designed to promote reliable feeding and extraction in bolt-action, semi-automatic, and automatic firearms alike, under extreme conditions. .338 Lapua Magnum maximum CIP cartridge dimensions. All sizes in millimeters. Americans would define the shoulder angle at alpha/2 per mil 20 degrees. The common rifling twist rate for this cartridge is 254 mm, 6 grooves, a lands equals 8.38 mm, a grooves equals 8.58 mm, land width equals 2.79 mm and the primer type is large rifle magnum. According to the official CIP Decisions and Tables edition 2007, the .338 Lapua Magnum case can handle up to 420.00 mpmax piezo pressure. This now prevails over the CIP Decisions and Tables edition 2003, that rated the .338 Lapua Magnum at 470.00 mpmax maximum piezo pressure. The 470.00 mpmax maximum piezo pressure CIP ruling for the .300 Lapua Magnum cartridge, which is based on the same case, was not accordingly changed. In CIP-regulated countries, every rifle cartridge combo has to be proofed at 125% of the prevailing maximum CIP pressure to certify it for sale to consumers. This means that .338 Lapua Magnum chambered arms in CIP-regulated countries are currently proof-tested at 525.00 mppe piezo pressure. Lapua is ambivalent on the maximum piezo pressure of this cartridge. In the article From an American Dream to a Finnish Success Story by Jan Pojoispa, Currency Lapua propagates the CIP 2007 ruling of 420.00 mp maximum piezo pressure. To further complicate matters, the mentioned 56,000 Cuban pesos CIP copper crusher pressure in this article would translate in a per mil 447.50 mp CIP piezo pressure according to a study on the conversion from cup to PSI for rifle cartridges by Denton Bramwell. The CIP 2003 ruling of 470.00 mp piezo pressure is corroborated by Lapua Australia in the History and Development of the .338 Lapua Magnum article by Alan C. Paulson. A reverse engineering simulation with quick-load internal ballistic software predicted that Lapua load their factory .338 Lapua Magnum ammunition at a per mil 420.00 mp piezo pressure, as Alan C. Paulson asserts in his article. The large bolt face combined with a high maximum pressure means that the .338 Lapua Magnum should only be chambered in rifles that are capable of handling such large and fierce cartridges and thus high bolt thrust safely. Chambering such powerful Super Magnum cartridges in rifles intended for normal Magnum rifle cartridges and using high-pressure loads can cause serious or fatal injury to the shooter and bystanders. The American .338-378 Weatherby Magnum cartridge introduced in 1998 and the American .338 Remington Ultra Magnum cartridge introduced in 2000 are probably the closest currently commercially available ballistic twins of the .338 Lapua Magnum. The .338-378 Weatherby Magnum is however a belted cartridge and the .338 Remington Ultra Magnum is a rebated rim cartridge. Supersonic range performance of the .338 Lapua Magnum, performance with CIP-conform cartridges. For a typical .338 Lapua Magnum high-end factory military sniper rifle like the Sako TRG-42 with a 690 on long 305 on rifling twist rate barrel at sea level, 1,500 am is considered to be the maximum shooting distance for man-sized targets. When using standard Lapua military 16.2 AG loads it has a supersonic range of 1,500 am under warm summer conditions at a muzzle velocity of 915 ams. However, to be able to maintain 80 to 90% hit probability on non-moving 45 ACMA, A90 ACM reactive army targets, this maximum shooting distance has to be reduced to 1,300 meters at freezing point conditions or 1,100 am in Arctic winter conditions, when the muzzle velocity may drop to 880 ams. That is only during optimal warm summer conditions the 1,500 am maximum shooting distance is realistically achievable. Loaded with more aerodynamic very low drag bullets such as the traditionally lead cord 19.44G Lapua GB528 VLD bullet or the Lost River Ballistics J40.338 17.5 gram CNC manufactured monometal bullet, the long-range performance and supersonic range of .338 Lapua Magnum rifles can be improved. These longer very low drag bullets require a 254 ohm twist rate to stabilize them. Due to the lower practically possible muzzle velocities for a relative heavy bullet like the 19.44G Lapua GB528 VLD bullet, it gains about 104 am extra supersonic range under international standard atmosphere sea level conditions at a muzzle velocity of 837 ams when compared to the standard 16.2G Lapua GB488 VLD at a muzzle velocity of 915 ams. For significant supersonic range improvement, the aerodynamic efficiency of the employed bullets has to be significantly improved without sacrificing a lot of practically achievable muzzle velocity, meaning that besides the coefficient of drag of the projectile weight is also an important parameter for its actual downrange flight behavior. The .338 17.5 gram Lost River Ballistic Technologies J40 match bullet made out of a copper-nickel alloy is one of the most aerodynamic .338 caliber bullets available. It has an 1,800 am supersonic range under optimal warm summer conditions at a muzzle velocity of 869 ams. This makes engaging static targets up to 1,800 am feasible. Performance improvement experiments with non-CIP conform cartridges, improvement beyond this standard while still using standard .338 Lapua Magnum brass is possible, but the bullets have to be very long and the normal cartridge overall length of 93.5 ohm has to be exceeded, making such cartridges wildcats. The common 254 ohm rifling twist rate also has to be tightened to stabilize very long projectiles. Such commercially non-existent cartridges are termed wildcats. The use of a wildcat .338 Lapua Magnum-based cartridge demands the use of a custom or customized rifle with an appropriately cut chamber and fast twist bore. The firearm action and if a repeating arm is required, the magazine must also be able to cope with dimensional increases. An example of such a special .338 caliber extreme range bullet is the German CNC manufactured mono-metal 18.92 gram LM105. The LM105 has a supersonic range of a per mil 1,860 meters at a muzzle velocity of 915 meters per second under international standard atmosphere sea level conditions. The 2010 version of the LM105 bullet has an overall length of 54.3 mm or 6.33 calibers and derives its exceptional low drag from a radical LD hook or Sears hook profile in the bullet's nose area. Rifles chambered for this Wildcat cartridge, with a cartridge overall length of 105 mm, and equipped with custom-made 178 progressive twist rate 900 mm long barrels with a 2° cone angle cone area, finished first and second at several long-range competitions. Its most recent win was in an international Special Forces and Police sniper competition in Switzerland against rifles chambered for 7.62A. 51 mm NATO Opta .50 BMG at ranges from 100 m - 1500 m. The LM105 bullet exhibited its very low wind drift susceptibility notably at ranges beyond 800 meters. A real-world average G1BC of a per mil 0.83 or a G7BC of a per mil 0.42 is commonly adopted by the users of this bullet for making long-range trajectory predictions using ballistics calculators. In contrast, the LM105 designer Lutz paragraph layer originally calculated an optimistic G1BC of a per mil 0.93 and a supersonic range of a per mil 2000 meters at a muzzle velocity of 915 meters per second under international standard atmosphere sea level conditions. The .343 Lapua Magnum LM107 was a Wildcat cartridge under development based on the standard .338 Lapua Magnum cartridge case. The LM107 was hoped to boost the ballistic performance of the LM105 by achieving an increase in supersonic range. The 19.3G LM107 projectile design is 59 mm long and has a Hulk-profiled nose and an Adams-profiled tail. The rifling twist rate for the .343 Lapua Magnum LM107 Wildcat cartridge was chosen at 180 ohm, a lands equals 8.72 ohm, a grooves equals 8.45 ohm, and loaded with the LM107 projectile has a cartridge overall length of 107 mm. The length of the neck is increased from 8.31 to 8.50 ohm to support the bigger LM107 bullet. Several other dimensions of the .338 Lapua Magnum parental cartridge are also changed. The shoulder angle gets steepened from 40° to 60° and the body taper is set at 1°. The throat area is set at a 2° cone angle. All these modifications make the .343 Lapua Magnum a fairly comprehensively revised Wildcat cartridge. Out of a 900 mm long progressive twist barrel, Mr. paragraph layer expected to achieve 909 meters per second muzzle velocity. If paragraph layer's design assumptions are correct, the LM107 projectile with a calculated G1BC of 1.02 will offer a supersonic range of a per mil 2170 meters at a muzzle velocity of 909 meters per second under international standard atmosphere sea level conditions. .338 Lapua Magnum as a parent case, the .300 Lapua Magnum, the commercially successful .338 Lapua Magnum cartridge, has functioned as the parent case for the .300 Lapua Magnum, which is essentially a neck-down version of the .338 Lapua Magnum. The .338 cartridge case was used for this since it has the capability to operate with high chamber pressures which, combined with smaller and hence lighter bullets, result in very high muzzle velocities. The Finnish ammunition manufacturer Lapua got the .300 Lapua Magnum CIP certified, so it became an officially registered and sanctioned member of the Finnish family of Super Magnum rifle cartridges. The .300 Lapua Magnum is not commercially available and currently exists only as a CIP datasheet. It is however still used by a few shooters who produce the cases from .338 Lapua Magnum brass by reshaping the shoulder and neck, and hand-loading it with .30 caliber bullets. The .300 Lapua Magnum has a 7.33 ml cartridge case capacity. .300 Lapua Magnum maximum CIP cartridge dimensions. All sizes in millimeters. Americans would define the shoulder angle at alpha/2 a per mil 25 degrees. The common rifling twist rate for this cartridge is 240 ohm, 4 grooves, a lands equals 7.62 ohm, A grooves equals 7.82 mm, land width equals 4.47 mm and the primer type is large rifle Magnum. According to the official CIP rulings, the .300 Lapua Magnum can handle up to 440.00 mpmax piezo pressure. This now prevails over the CIP decisions and tables edition 2007, that rated the .300 Lapua Magnum at 470.00 mpmax piezo pressure. In CIP-regulated countries, every rifle cartridge combo has to be proofed at 125% of this maximum CIP pressure to certified for sale to consumers. This means that .300 Lapua Magnum chambered arms in CIP-regulated countries are currently proof-tested at 550.00 mpe piezo pressure. This for rifles' very high maximum allowed chamber pressure level indicates that the cases of the .300 and .338 Lapua Magnum are built extremely sturdy to cope with this for rifles' very high operating pressure. The large bolt face combined with the high 470 mph maximum pressure makes that the .300 Lapua Magnum should only be chambered in rifles that are capable of handling such large and fierce cartridges and thus high bolt thrust safely. Chambering such powerful Super Magnum cartridges in rifles intended for normal Magnum rifle cartridges and using 470 mph loads can cause serious or fatal injury to the shooter and bystanders. The 7.62 UKM, the .338 Lapua Magnum cartridge is also used as the parent case for the German-designed 7.62 UKM, which is essentially a neck-down shortened version of the .338 Lapua Magnum. The use of the .338 cartridge case with its capability to operate at high chamber pressures resulted in Magnum case capable of producing high muzzle velocities. The 7.62 UKM was developed by Michael Weeker Paragraph TTER and was CIP certified in 2002, making it an officially registered and sanctioned member of the Finnish family of Super Magnum rifle cartridges. The 7.62 UKM is not commercially available and currently exists only as a CIP datasheet. It is however still used by a few shooters who produce the cases from .338 Lapua Magnum brass by reshaping the shoulder and neck, and hand-loading it with .30 caliber bullets. The 7.62 UKM has a 5.84 ml cartridge case capacity. 7.62 UKM maximum CIP cartridge dimensions. All sizes in millimeters. Americans would define the shoulder angle at alpha/2 per mil 20 degrees. The common rifling twist rate for this cartridge is 254 mm, 6 grooves, a lands equals 7.62 mm, a grooves equals 7.82 mm, land width equals 2.79 mm and the primer type is large rifle Magnum. According to the official CIP rulings, the 7.62 UKM Magnum can handle up to 440.00 mpmax piezo pressure. This now prevails over the CIP decisions and tables edition 2007, that rated the 7.62 UKM at 470.00 mpmax piezo pressure. In CIP-regulated countries, every rifle cartridge combo has to be proofed at 125% of this maximum CIP pressure to certified for sale to consumers. This means that 7.62 UKM chambered arms in CIP-regulated countries are currently proof-tested at 550.00 mpe piezo pressure. Wildcats. The .338 Lapua Magnum case is also used as the parent case for a host of modified variants that are not officially registered with or sanctioned by CIP. Or its American equivalent, SAAMI. Such cartridges which use commercial factory cases are generally known as Wildcats. By changing the shape of standard factory cases, the Wildcat generally increases the case capacity of the factory parent cartridge case, allowing more propellant to be used to generate higher velocities. Besides changing the shape and internal volume of the parent cartridge case, Wildcatters also can change the original caliber. A reason to change the original caliber can be to comply with a minimal permitted caliber or bullet weight for the legal hunting of certain species of game. Because the .338 Lapua offers a large and exceptionally sturdy, pressure-resistant cartridge case that can be relatively easily reloaded and hence be reused several times. It has become quite popular amongst wildcatters. With the .338 Lapua Magnum as the parent case, wildcatters have created 7 .30, .30 Wolf, 8 LM101, .338, .343, 9.3 .375 and .50 caliber variants. The current bench-rest 1,000-yard 5-shot group world record holder Tom Zava used a .300 Hulk Wildcat cartridge, which is basically a neck-down, blown-out, shortened .338 Lapua Magnum variant, to achieve a 1.403-inch diameter 5-shot group on July 7, 2007. See also, .300 Lapua Magnum, .338 Norma Magnum, 6.5A, 47mm Lapua, 7.62 UKM, 8mm caliber, quick loader Euro-internal ballistics predictor computer program for firearms, list of firearms, list of rifle cartridges, table of handgun and rifle cartridges, list of sniper rifles. Notes: the Finnish Army found out during a test trials program and 7 years of service that the barrels of their Sako TRG-42 sniper rifles lasted 7,000 to 8,000 rounds with Lapua lock base B408 factory ammunition, before showing impermissible accuracy decay. The Finnish Army consistent accuracy requirement for these rifles is a per mil 1 currency MOA at 1,000 m. If this requirement is not met, the TRG-42 gets a new barrel. This is normal practice for active high-performance precision rifle operators who regard barrels as expendable items. The continuous use of very powerful handloads resulted in much quicker throat erosion, reducing the TRG-42 barrel's accuracy life to 1,500 to 2,000 rounds. In 1990, the U.S. Military Adjutant General's Office issued a legal opinion holding that the Sierra Matchkin bullet, despite being a hollow point design, is not designed specifically to cause greater damage or suffering in a human target, and in fact normally does not create a wound readily distinguishable from wounds caused by conventional full metal jacket bullets, and is therefore in their opinion legal under the Hague Convention for Use in War. References. External links: Lapua official site, Lapua product brochure. .338 Lapua Magnum ammunition, modern firearms list of sniper rifles, PGW Defense Technology, manufacturer, PGW DTI Timberwolf Tactical Rifle, .338 Lapua Magnum reloading data at Reloader's Nest, Lutz Mar paragraph layers. .338 Lapua Magnum page, LM101 long-range bullet for an 8mm .338 Lapua Magnum high-performance Wildcat cartridge, LM105 long-range bullet for the .338 Lapua Magnum, Lapua 338 Magnum, exclusive caliber for the new age of sniping, .338 Lapua Magnum Generation 2 Ordnance Development Program by Canna Longbranch, cartridges for long-range sniping rifles by Anthony G. Williams, CIPTDCC Sheet 338 Lapua Mag.